All right, so today we're going to talk about graphing. So why is graphing important? It's a way to organize information. And so when we graph, it provides a visual representation of the data we collected. So sometimes it's hard to just look at numbers. So what we can do instead is we can make a graph to look for trends. So graphs, they can look like this. So instead of looking at numbers, we can see, the general trend is pointing upwards, and so it's easier for us to see. It's a visual way of expressing our data. So there's two types of graphs that I want you to be familiar with. One is the bar graph, and it shows a comparison between different categories. So for example, here we have the number of students. We're comparing boys and girls over the number of years. And so bar graphs are pretty good for showing a comparison. Line graphs is usually when you want to see a trend, so a trend over time. Usually the x-axis here, for example, here, is over time. And we can also use it to show a comparison between different categories. What is it that we need on a graph? So there's 5 major parts. You need a title, you need to label your x-axis, y-axis, you need a scale, and then you need a key. Especially, now you don't always need a key, but you need a key if you have like multiple lines or multiple graphs. For example, if we go back, notice that there's a key here, right? Okay. So let's first talk about a title. So we're going to go over the 5 major parts. So in this, what would be an appropriate title? So I look at it, and what we're looking at is the number of students who are boys and girls over a period of time. So we want our title to be shorter. We don't want to write that whole thing. So we can say maybe number of female and male students over time. Something like that. So that would be an appropriate, because it basically summarizes the graph in 5 to 10 words. Go ahead and try on your own this one. So what would be an appropriate title here? So it looks like this would be, these are temperatures over the months, right? So we could say maybe temperature over, or maybe even during, or temperatures by month, something like that. All right. All right, so now we know a title should be concise, but they should also summarize what the graph is about. So we now have to label the y and the x-axes. And so one way that I remember this is something called dry mix. So dry, or D, stands for the dependent variable. It's the result, and it's always found on the y-axis. The manipulated variable, the one that you can change, is the independent variable, always found on the x-axis. So the independent variable is always on the x-axis, the dependent variable is always on the y-axis. If you ever forget, just dry mix. So dry, the result, the dependent variable is on the y-axis, mix. The manipulated independent variable is on the x-axis, okay? And then how big do I make my graph? So if we look at a graph, the graph should be, each line should be equal in distance. What I mean by that is each interval should be the same. So like if I think, oh, let's go by fives, this should be 5, 10, 15, 20, 25, 30, and so on. And then if I'm going, I can go by twos here, 2, 4, 6, 8, 10, right? So all I'm saying is these are intervals by 2. So we have to keep, whereas this is intervals by 5. So the intervals have to be the same. Okay? And you determine the intervals by the data that's given to you. Oops. Well, let's open this again. All right. So we're going to do a graph together. First of all, it says graph the following information. It says what is the independent variable, what is the dependent variable. So we have the average spring temperature and then the number of peaches. So one hint I could give you, and this rule generally works, is the independent variable on the x-axis is usually the first column. So it's the spring temperature. That's the thing that can change, right? And then the dependent variable is the number of peaches. So the number of peaches is probably is dependent on the temperature. So like, I don't know, if it's hotter, we might get less peaches. If it's colder, we might get more peaches. So this is the this is the independent variable. And this is the dependent. So independent and dry mix is on the x-axis, dependent is on the y-axis. So on your own, let's see if you can try to graph this. So I have a graph here, and you know what I'm going to do? Let me copy and paste this over. All right, so that way we can have it in the same place. So I want you to make a graph. So what's the first thing we need on a graph? Well, I would add so let's remember, here's your independent variable. So that's on your x-axis. Here's your dependent variable. And so that's on your y. So let's make your axes first. And I can't draw very well, but I can do this. And so make sure it's on the line. All right, so our independent variable is on the x-axis. So our independent variable, we're going to label. So this is the average spring temperature in degrees Fahrenheit. And then the number of peaches, that's on your y-axis. That's your dependent variable. So I'm going to put number of peaches. All right. So if you look, the average spring temperature, the highest is like 95. Do you see that? And the lowest is 70. So we actually, what we can do is, since the temperature doesn't go all the way down to 0, you can actually start at whatever number you choose. So I'm going to actually start at 70. So I'm going to make the first number 70. And what I'm going to do is, I think I'll make, let's see, if I go by twos, I think that won't be enough, because this will be 72, 74, 76, 78, 80, 82, 84, 86, 88, 90, 92, 94, 96, 98. So actually, I think I can go by twos. So what I'm going to do is, if I start at 70, this line will be 72, this will be 74, and I'm going to go every other. This is 76, this is 78. The reason why I'm going every other is just because I don't have enough space. So that's 84, 86, 88, 90, 92, 94, 96, 98. And then if I go up here, you'll see that the lowest number is 107, the highest is 348. So we're going to have to go by bigger numbers here. I probably should start at 100. I might have to go by 20s, I think. Yeah, something like that. Let's try it out. So let's make this 100, since 107 is our smallest number. So we're going to go by 20. So here's 120, and then notice I'm making the marks on the line. 140, 160, 180. Here's 200, 220, 240, 260, 280, 300, 340, 360, 380. Okay, and I think I'm good because the highest is 348. All right, so I've labeled my axes. They're on the correct axes. My independent variable is on the x-axis. My dependent variable is on the y-axis, right? So at this point, what I'm going to do now is I'm going to go ahead and put in my my sections here, my points. So my first point is 70, 214, right? So 70 is here, and 214 is about, so this is 200, this is 220, so it's like right there. And then 86, so 86 is over here, 348, so I find the, so it looks like here. And then 89 is around here, 305 is like here, so it should be around there. 90 and 202, so 90 is here, 202, and then 92 is 176, 93 is here, I believe, right? So 93 and 180 is here. Oh, nope, 180 is here. And then 95 and 107 is down here. Oops. So, and then I'm going to connect it because it's a line graph, so. All right, so that's my trend. And then I want you to think of a title. So we are figuring out what the number of peaches at different temperatures. So number of peaches at different temperatures. Okay, and that's it. So if you look at your graphing homework, there's one side so number 1 and number 2 are homework, and then if you would like 5 extra points, you can do 3 and 4 on the back as extra credit. But at minimum, you have to do 1 and 2. Okay.